Hello, my fellow YouTubers. This is Roy back again. Let's go Leedskalnin today. Took apart his wheel. There's the flywheel. There's the shaft with the brake hub. There's all the magnets. There's a couple PMHs. There's the ring gear. There's the other ring gear down bottom. Why did I take my wheel apart? Why haven't I been playing around with Leedskalnin? I sort of ask myself these questions. And I realized there ain't much going on there. How do you get some magnets to do magic? Well, thanks to this gentleman, I think he figured it out. And how he figured it out is all right here in this picture. If you look, you see a wheel that he has his hand attached to with all those magnets. Over here, he's got a capacitor. He's got a pipe that goes down to the ground. In the front here, he has some sort of pickup. It's obviously attached to the chains. And he filed a patent. And nobody talks about the patent. Nobody talks about the patent. Because nobody can find the patent. Nobody can find anything about applied for a patent. If anybody does, the search is on. So what we're going to do here is we're going to do step by step how to build edge wheels. If you're able to get your hands on these V-shaped magnets, they must be magnets. They have to be magnets. They can't just be metal bars to be authentic. But if you want to make it out of metal bars and attach neodymium, I don't know if you can still get north and south in a circle, I guess, with the neodymiums, north, south, north, south. But the way these V-shape work is it's creating a neutral in the center. And if you think of an atom, the atom's the same way. The neutral is towards the center of the nuclei of the atom. So there's some similarities there that we'll get into another day. But I want to show you guys something that's pretty cool, way beyond cool. But here's the pipe. We're going to put edge wheel back together. We're going to show you guys how to build it step by step. And we're going to incorporate the pipe to work on what I believe is Leedskalnin's patent. Now you got to think about that. We're talking about in the 40s. If you look at his age there, he's pretty damn old. Pretty damn old. So this got to be in the 40s, okay? And he's already built the castle. He decided he was bored. He had to do something, threw himself in to learn about electricity. And if he was going to apply a patent for electricity, we already did everything with electricity at that time, as far as making motors, going on and on and on. What did he have to bring to make a patent? You know what I mean? I mean, basically, what do you have here? Some magnets and a coil there, and you're going to get very little power in retrospect of how we make electricity. So what I'm saying is, I got into thinking. I started looking more into this section here where the pipe is and what's on top of the pipe. And what makes sense to me is when a magnet passes the metal. He talks about this in one of his in his magnetic current about if you want to make it even stronger with no loss, then just take a coil, okay, with an iron core, put it in a casing, and tie one end together, and you'll have the strongest strength, pulling strength. So, by that being said, with no further ado, visualize the magnets passing the front here, because this is what we're going to work on. North, south, north, south. What I've noticed here is here's a ring magnet. Here's the voltmeter. I got a capacitor. We are going to charge this capacitor and something special. Once, if anybody knows anything out there about the PMH, Ed's PMH, this thing, you can stick a piece of metal across the front when you give it just a little tap on a battery and put a charge in there through the two coils, it'll stick. Well, guess what? This pipe acts the same way in a sense, and I'm going to show you electrically how it acts. So let's go ahead and we're going to put, I got a diode on the positive side, so we're going to touch the outside of the diode, and there's no volts or anything up on there, okay? So what we're going to do is we're going to pass, like if this was the wheel, and I want you to watch there you go. There you go. So just watch the voltmeter. So you got things showing up, okay? And all I'm doing is just passing in front of it, okay? Now, what I just did was charge up this ground pipe, which goes in deep into the ground. It's got to be 6 feet down in there. And I charged up that pipe, like Ed's PMH. Now we're going to go ahead and take this and put it on the other side, okay? And I'm already been charging it. It's 1.53.9. So we are going to increase it by putting the magnet in front of it, and we are charging this capacitor right now. All right. So now I'm not even using the magnet right now, and there's a field running in that metal that's going into the ground and causing a break. The field running on the metal itself, because look at the reaction what the magnet is doing to the. Let me get that glare out of there. Sorry about that, guys. Watch. I've just moved the magnet and it just went crazy. Look how it's reacting to the metal. This thing is so responsive right now. This is what I believe Ed was filing a patent for. He had the wheel set in front of the pipe. He had his coil, which is up on the wall, and it fits right down in there. Capacitor up top charging the capacitor, which we're doing here. And he was making the wheel and the pipe like a PMH. So basically you got a flow and a current. Well, a flow and a current, it's got to be, because you got, well, let's just say this. To have current, you got to have volts and you got to have amps. And you times those two and you'll get your power, okay? So we need to get the wheel back in place. We need to get the wheel turning. We need to charge the capacitor. And then we need to release that capacitor and be able to recharge it again and release it. And after we release it, we'll figure out what do we do with it from there. I mean, if we're going to send it out as a signal, or are we going to, because he was into radios, or are we going to take it and put it back maybe into Ed's PMH? And if you think about the PMH, if one side is 1,500 turns of 16 gauge magnetic wire, and the other side is, and there's wound the opposite direction, and you tie in your ends up on your poles here, you literally have slamming with an enormous amount of current, because that current that would be coming from that capacitor would slam through here. What I could tie this to the capacitor, so basically you would have a strong as hell positive and negative induction going back into the coil, which itself could turn the wheel. We already showed how that you could turn the wheel magnetically by a field magnet, but we would use its own power to go back into itself so the wheel would turn. Meanwhile, you could charge batteries from it, or you could do other things. Ed Leedskalnin's wheel. It's time to recharge these puppies, put it back together. Guys, girls, whoever, stay tuned. Ed Leedskalnin's back. Where are we at on this thing? Still climbing slowly by itself. Let's put that magnet in front of it again. So I'm just waving the magnet. Now remember, I'm only putting one pole in it. All right, let's disconnect this going into there. Let's go back on this side. So we're just looking at the voltmeter now at 0. And let me dead short this capacitor. I'm going to dead short it. Hopefully we can dead short. Let me see. I'm going to dead short the capacitor. Get it to 0. Yeah, it's down right now. So let's go ahead and wave the magnet and watch it charge. Now it's charging on its own. I'm not even waving the magnet anymore. So we have a magnetic flow, just like the PMH, stuck inside the pipe. It's the oscillation between the coil, the center insulated core of iron, rebar, and the key is to have 2 grounds on a bifilar turnings. So I got a bifilar set up here. So we had created almost like a tank circuit that is at 15.3 volts, waving and like kind of recharging. I'm still in study of this to see if, obviously, the hole is big. So this is just a test, because I knew there was more to something about Ed's wheel than the way I had it just sitting here. Plus, the key thing is the magnets I had on the wheel. If you go to do a continuity test between them and the block itself, here's the motor block down here. The block was stiffening up. You know, they're not really designed, these motor blocks, for standing up straight with a big amount of weight on it. So we're going to recondition that to make that better, and make the symmetrical part of the magnets better and more perfectly round. And we'll take Ed for a run again. All right, guys, you stay tuned. See that charging? 21.7. Charging on its own, all by itself. Free energy, baby. Free energy. Ed Leedskalnin. Take me home, Ed. Take me home.